have asked me about some NLP like data annotation tool, right? Yeah, you can talk about architecture. Okay. Okay. So let me name some of the annotation tool inside NLP. First of all, okay. So there are some like NLP annotation tool you will get. So I'm naming some of the top annotation tool you can use. Like there is a Brat is there. Okay. Then Docano is there. Sorry. Then light tag is also there. Then you have something called tag talk. Okay. Then there is another one called prodigy, sorry. Okay. So mostly actually we'll be using this one. Okay. Because this one is pretty good. And this is paid, I guess. Okay. And it supports actually all the, task inside your annotation, data annotation, everything. Like you can also use Prodigy as NER annotation. Okay. Data augmentation. Okay. Actually, many things is possible. So if you just search Prodigy, so you will get their website. Okay. Try to explore this one. I think it's a paid, but as of now, it's fine. If you're not using, it's fine. So these are some tools, okay, you can use inside NLP. Now let's discuss about today's agenda. See, which task needs annotation? Like whenever you will be implementing NER, like name entity recognition, at that time you need to annotate your data. Suppose you have a data. Suppose my name is Bappy. Okay. I love to visit USA. Okay. So here, this is your raw text, right? So whenever you will be NER means name entity recognition. Okay. So the basically task of NER is like to find out the entity, okay, of this each and every word. Suppose what is my here? Okay. You have to annotate. Okay. Then what is name? Okay. So basically you will be considering my name is all are as a objects. Okay. Object type. And here Bappy is a name. So you will tag is at a name. Okay. Name. Then again it's objects, again it's objects, again it's objects. This is a country. Okay. So basically when I think you have heard of resume parser. Okay. Like in company, if you pass your resume, automatically it will be extract your experience, number of experience, your email address, right? Okay. So how then your skills, how basically it identifies, okay, like from all these unstructured text. Okay, because they apply these kinds of ACR, sorry, NER. Okay, they train their custom NER on the resume data. And suppose you have written I have 10 years of experience. Okay, years of experience. So first of all, they have to annotate the data, so they will be considering all the thing as objects. Then years of experience, they will consider experience. Okay, experience as an entity. So whenever you are giving your resume, it will automatically identify this is your years of experience. Okay, this will be extracted. Yeah. So you will use this annotation tool, actually, this Prodigy. I showed you this one, right? So to do this kinds of annotation, you have to use this other tool. Okay. You just have to select the text and mark it as a like your entity name there. I think there is one free example, NER annotation. See, that's how actually. If you pass your text, you just see, this is one example, 5 years of experience. They have just selected, they just give a one color, okay, and they mark it as a experience. That's actually what you can do your things, okay. Suppose if I pass one text file here. See, in this text file, this text has been written, okay. Now, if I want to annotate something here, so what I will do, I'll just select there is no available candy tag. Okay, so let's give test, okay, as name test. Now just select text. Okay, now can you see it has been annotated? Okay, it is annotated as test. Okay, now we can like take a new tag. Suppose let's take what name. Okay, suppose this is your name, Yash. Just select the name and just do annotate. Okay, name has been annotated. Now if you save this file, so it will consider all the, I mean, tags, okay, in a JSON format, I think. Yes, I can share the link. So we can try it later on, okay, because every tools has different technique, okay, you can do it. So now let's start with our today's agenda. So today actually we'll be starting with RNN. Okay, that means recurrent neural networks. Then I will show you what is sequential learning. Okay, then some drawbacks in ANN or CNN. Okay, then types of sequential learning, types of you can talk about types of RNN, and at the last I will show you one code example of RNN using Keras. We'll be building one sentiment analysis. Okay. The parts of speech tagging will be using many where, okay, like I showed you one example, resume parsing. Here you need parts of speech tagging. Okay, here basically you are tagging parts of speech tagging, basically you are doing. Okay, then chatbots need parts of speech tagging, conversational agent needs parts of speech tagging. Okay, then apart from there are some you can say variant of RNN, like there were some issue with the RNN, so that's why researcher has came up with some of the architecture, like you will see LSTM, long short-term memory, and GRU, gated recurrent unit. Okay, these two will be covered. After that, you will be starting with encoder, decoder. Okay, so this will help you to understand the transformers. Okay, so once transformer you got to understand, then you will be understanding the BART, GPT. Okay, these are the thing, because every lecture has you can say connected with another one. Okay, so guys, is it fine? Can I start? Just give me a yes or no. Okay, so guys, I think so far you have learned ANN. Okay, artificial neural network. No, Paul sir is not going to join today. He has some other work. Okay, today I will be taking the session, so I think mostly we'll be taking, okay, after today. Okay, just focus on that. Okay, just try to first of all see what is RNN all about. Okay, because this is going to help you to understand the further process. Okay, so as of now you have learned ANN, and I think you have applied ANN on tabular data. Sorry, tabular data. Am I right, guys? Okay, then you have worked with CNN. Okay, and there you use images, or you can say videos. Correct. But today we are going to see another neural network called RNN. That means recurrent neural network. So RNN is a type of sequential model. No, actually, voice analysis you can't use CNN. Okay, you can use CNN architecture, but there are some drawbacks. Okay, that is why I'm explaining. Okay, today, what is the drawback first of all? Then you will be able to understand why RNN is needed. Okay, first of all, see what is sequential learning and what is sequential data. First of all, okay, you need to understand, because tabular it's not a sequential data. Correct, guys? Images is not a sequential data. Suppose if I give you one tabular example, suppose if I take your Titanic example. Okay, Titanic example. So Titanic data, suppose there were name. Okay, fair. Sorry. Okay, fair. Then this person has survived or not. Okay, survived or not. So suppose this is your data. So see, I think you are familiar with this data set, right? Suppose name is X. Okay, fair is like 2K. This person didn't survive. Okay, I think you worked with this data, right? Tabular means table data. Okay, table data, like you have Excel table data. Okay, like you have x feature and your y feature. Okay, guys, I am expecting machine learning, right? These kinds of data you have already worked. SQL format, JSON format, it doesn't matter, but at least you are trying to convert to a pandas data frame. Okay, and after converting, you can see your x feature and y feature. Okay, you have your x, you have a y. Okay, this is the tabular data, right? Now tell me, my data is like that: name, fair, survive. Now if I flip the data a little bit, suppose if I give fair, then name, okay, then survive, will it cause in my prediction anything? Is there, I mean, would be any issue, guys? Right? No issue, right? Because I can take any of the column first. Okay, it doesn't matter. Okay, now if I talk about CNN, okay, that means let's okay, now if I consider CNN, suppose CNN is what, like you are working with images. Okay, and images is nothing but it's a pixel only. Okay, it's a pixel. So if you see, if I just try to get the pixel out, like in an array, this pixel I will take out. So suppose X, Y, Z, like that. So this is one of the, like you can say, I mean, data. So here actually order doesn't matter. Okay, somehow you can take the pixel or you can do the convolution. Okay, extract the feature, and if you have the feature, it would be able to learn. Okay, but if I talk about RNN, okay, RNN, it's a sequential model. I already told you, sequential model. Now, if I give you one example here, text data. Okay, suppose if I write one text here, I am Bappy. Okay, now can you tell me this data is sequential or not? I mean, non-sequential. Tell me, because if you see, every word has some kinds of sequence, right? It has some grammatical rules. Yesterday I think already discussed, like, right? Okay, because to understand this entire sentence, I need to also know the previous two words. Okay, suppose Bappy, just Bappy, I can't tell like what is this word mean, right? Yes. So to understand Bappy, actually I need to see this previous two word also. Okay, so it is following one sequence. Okay, guys. Yes. Now this is a little bit easy. Now just, I mean, try to increase the like sentence size. I am a data scientist. Okay, now see, this is more complex. Okay, now I mean, this is more hard to remember. Okay, now I need to understand this scientist, I need to know what was the previous word. Okay, all the previous word. So it is following one sequence. Now if I just randomly give anything, suppose am scientist, data, Bappy. Okay, I. Now is it readable, guys? Tell me, would you be able to understand? Like that, this, like this tabular data, if I just flip it, okay, is it readable? My model will understand or not? Just write yes or no. No, right? Yes, your CNN and ANN can't remember those previous input. Okay, I will show you one example, but your RNN can do it. Okay, because it has some feedback memory. Okay, So that is why sequential, whenever you are, first of all, you need to see the data. Okay, you need to understand the data type. Whenever you're taking text data, text is a sequential data. Okay. And I think apart from text, okay, apart from text, there are some other data also. Like text is a sequential data. I think some of you have worked on time series, right? Okay, time series also sequential data, right, guys? Then if I talk about speech is also sequential data. I think you have heard of DNA sequence. Okay, it is also sequential data. So these are the data actually sequential. Okay, so you can't apply ANN and CNN. Okay, here, because it can't get the contextual meaning or semantic meaning of your data. Okay, so to overcome this issue, we use RNN based neural network. Okay, that's why it's telling recurrent neural network. Okay, recurrent neural network. There is a term. Okay. Now, let me give you one example. Why to use RNN? Let me make one dummy data here. Yeah, ML, you can do it, but you won't be getting good results. That's why you used Arima, Sarima, right? LSTM. These are actually NLP based algorithm, RNN based algorithm, right? Vignesh. Okay. So let me create one dummy data here. So let's take some text. My name is Bappy. Okay. Let's assign some like level. Okay. Let's assign 0. Scroll down. Not able to text behind. Means, is it visible, guys, to all of you? My screen. Okay. Yeah. Now take another row. I am data scientist. Okay. Let's assign some thing here. Let's one. Now let's take another row. I love AI 0. Okay. Suppose this is one tabular data you have and you want to do text classification. I think you all know what is text classification. Okay. You already did in machine learning. Okay. Spam ham classification. Okay. Suppose this is one of the data I have prepared. Now, suppose you have assigned one ANN. Okay. Let's consider ANN first. So how you create ANN architecture? So suppose this is one neural network you have defined. This is nothing new, guys. I think you are getting, right? This is why you will be getting. Now, here, if I want to pass this data to my, suppose, neural network, okay. First of all, let me see how many unique words I have. Can you tell me what is the highest unique words? Which row it contains? My name is Bappy, right? 4. So first of all, I need to count the unique words. So here I have 4 unique words. I am. So here I have also 4 unique words and 3. Okay. So which is highest? 4. Okay. So I need to take 4 neuron here, because this should be my input, right, guys? If you know this one, let's consider this is one architecture I prepared. Okay. This is one architecture. So now if I want to pass this data to my neural network, so I can't do it, because if you see, it is written in text. Okay. First of all, what I need to do, I need to convert it to numbers. Okay. So yesterday I discussed like many technique you can follow. You can follow like a bag of word is there, TF-IDF is there, what to fake is there, one-hot encoding is there. So as per the simplicity, let's do it one-hot encoding. Okay, let's apply one-hot encoding. One-hot. Okay. So if you do one-hot encoding, so I know, I think you all know like how one-hot encoding works. First of all, it will see how many unique word, okay, all the corpus has. Okay, which is the highest unique word. If you see, it's a 4. Okay. Now, if I want to convert this rows to one-hot encoding, so what would be? So first of all, let's take the my. Okay. So how I will represent my? Suppose this is one big array I have taken. Inside, I want to represent my. So what I will write? 1, 0, 0, 0. Am I correct, guys? Is it correct? Okay. Now again, I need to give comma and take another list, and I need to represent name. Okay. So how I can represent? 0, 1, 0, 0. Okay. Now again, I will take one comma. I will assign one list. I want to represent is. So how I can do it? 0, 0, 0. Sorry, it would be 1. Okay. 0. Okay. That's how, I mean, I can also represent Bappy 0, 0, 0, 1. Okay. So this is my one row. Okay. This is my first row. That's how I need to do it for second row also. Okay. Third row also. Okay. So I think you got it, guys. Like this is nothing new, I think. Is it understandable, guys? Just tell me. Yes or no? Okay. Now I have my input data and it has been converted to what? It has been converted to your numerical form. Okay. Now what I will do, I will feed my data. So first of all, what I will take the first words. Okay. First words. That means my. So here, let's take first words. So this is my. So 0, 0, 0. So this is the my. So I will feed it. Okay. That's how I will take the second word. Okay. So what it was? 0, 1, 0, 0. I will feed it. I will take my third word. What it was? 0, 0, 1, 0. Feed it. I'll take my fourth word. Okay. So let me draw it. 0, 0, 0, 1. I'll feed it. Okay. Can I do it, guys? Like, does it make sense? Can I do it? All right. But now see what will happen. Okay. Now, so this is the first row I have inputted. Okay. I have given. Okay. Now let's take, just for the simplicity, I'm removing one. This one I'm removing. Okay. Just I'm keeping data scientist. Okay. Because your text can be random. Okay. It is not possible all the text will contain the same length, right? It may vary. Like for the first row, it is containing 4 words. Okay. Second, it is possible it will contain just 1 word, 2 words. Okay. It's also possible. So how many words you have here? You have 2. Okay. Only 2 unique words you have. Okay. Now, if you one hot this one. Okay. So what will happen? Now how many, I mean, what we had, just give me a minute, guys. Yeah, guys, am I audible? Hello. Okay. So now, if you if you do one hot code like this two words, okay. Yes. So now, what is the list you will get? Data 1, 0. Okay. And what you will get? 0, 0. And here also, if you do scientist, so you will get 0, 1, 0, 0. Now, if you see here, how many length I have in this list? I have fourth item, right? No, fourth item I have, right? Because here I have fourth words. Okay, now in the second row, how many item I have in this list, guys? 2. Okay, so now whether it is possible now, like suppose you are doing second iteration, at that time you are just passing these two things, okay? 0, 0, 1, 0. Okay, and these two things you are not passing. So will it work? Your neural network will work because it is accept. Okay, it will always accept fourth input. Okay, 4 input, but you are giving 2 input. Okay, will it throw error, right? Guys, I can't reduce the neurons here because I have already defined 4 neurons as the output. So I can change it. Okay, so this is one drawbacks in ANN. Okay, with the textual data. Okay, but if I want to make work this model, okay, I can do some tweaks here. Okay, let's do it. So what I can do, I think you have heard of paddings, guys. Paddings. Okay, so what you will do, you will apply paddings, and okay, where this is empty, you will just fill with 0. Yeah, I'm telling. Okay, we do it. We can do it. I see. I filled with 0. Now what will happen? Okay, just see here. Now just consider here. I had just fourth unique word. Okay, fourth unique word. But suppose you have a big corpus. Suppose you are working on IMDb. Okay, DB data. Suppose there you have 1,000 unique words. 1,000 unique words. Now, how your one-hot encoding will look like if you convert now this text to one-hot encoding. So first of all, I'm representing my, then okay, so my would be 1 and all the rest of the thing would be 0, right? Till 1,000. Okay, 1,000. Okay, now if you pass just 1,000 here, okay, just for one words, and now in the second row, it might contain just 4 words. Okay, so it forwards and rest of the thing will be 0. So what you are doing, you are putting unnecessary 0 information, and you are, like you can say, increasing the weights. Okay, increasing the features. Is it good? Because it will take a lots of computation. Just consider if you are taking 1,000, okay, as input. Okay, and if you just multiply with your neurons here, weights here, how many trainable parameter you will get, guys? I think this thing you can calculate if you have learned ANN. Is it make sense, guys, what I'm trying to say? Yes, I will tell you what will happen. Now, what I told, just tell me, is it clear or not? Okay, if you pass unnecessary zeros, so you are increasing the features. You are increasing the weights, okay? You are increasing the computational power. Okay? And here, if you see, it is not taking the contextual meaning of your text. You are unnecessarily just putting the numbers. Okay, at the end, it's a just dense layer, like fully connected. So which word, okay, when it will come, which word, where it will go, you can't tell anything. Everything would be randomly here. Okay. Now, suppose somehow you have trained this model. Now, during prediction, suppose there is one person, he has put something like that, like, hey, how are you? Okay. Hey, how are you? I'm good. Okay. Now, how many word you have? 1, 2, 3, 5, 4, 5, 6, 7. 7 unique word you have. And what was your input? It was 4. At that time, it will again fail. Guys, are you able to understand? Just write yes or no. Because I can't change my input layer. Okay. Is it fixed? It is always fixed. That's why I used tabular data. So in tabular data, my feature would be fixed. Okay. No, Vignesh, you are not like correct. Okay. Like adding too much of zeros. Okay. You are unnecessarily like creating too many neurons. Okay. Suppose 1000 input means what? 1000 input means what? You are taking 1000 more unit here. Okay. 1000 more unit here. Now calculated the parameter. It's not like that. And it's not recommended. You have to take zeros. Okay. So that's why we always try to convert to a number float. At least we have some value after zeros. Okay. Why floating is needed? Suppose everywhere you will see in the weights or anywhere we are trying to convert our number to floats, float 32, float 64. Why? Because we want to make non-zero number. Okay. Now, is it clear, guys? What is the drawbacks? Why we can't use ANN? Because textual data is different. Okay, it may differ anytime, but your tabular data, it would be fixed. Image data, it would be fixed. Like there are some image dimension here following 32, 32, 3. Okay, every time you're following this one only. Okay, textual data, you have fixed X size. Okay, you have fixed Y size. But in textual data, it's not possible. Suppose your number 1 row will contain my name is, okay, Bappy. Second row will contain data scientist. Okay. Now let's wrap up. Note all the problem. Okay. Note all the problem. First, it was text input, varying size. Second one, zero padding. That means unnecessary computation. Okay, computation you are doing. Then 3, prediction problem. Okay. Now, fourth thing is losing sequential information. Okay. Hope it should be clear all, right? These are the drawback actually. Okay, now let's see first of all what is sequential learning. Okay, why we can't use this one. Okay, so to overcome this one, there is neural network researcher has proposed. It was proposed in 1918 around. Okay, we call it RNN. That means recurrent neural network. Okay. Now let me show you one thing. Yeah. So I already discussed recurrent neural network. Great for modeling sequential data. Okay. Variable length Pallavi. I already discussed, like you can add zero padding. Okay, zero padding you can do. But what is the drawback of zero padding? You are doing unnecessary computation. It's just a basics ANN. Just try to get it. Okay. And if you are also passing zero padding also during prediction, it may vary. Suppose here you are passing, hey, how are you? I'm good. That means your length of the input is 7 during prediction, but your model takes only 4 input. Will it work? Okay. And again, you are not keeping the semantic meaning. Okay. Like you can say semantic information, like the sequential information you can't pass here. You are doing some random one or encoding, you are passing to your fully connected neural network. Again, it is going to be random. Okay, like after my name would become, after name is would become, it only able to understand. Okay, but in NLP we always need to follow the sequential manner. Like after my name will come, after name is will come. Okay, what was the previous input of Bappy? That was is. Okay, what was the previous input of is? Okay, it was name. That's how you need to see the previous input as well. Okay, but if I suppose you are doing image classification. Okay, suppose uh, there is one image. Okay, and if you have applied convolution, some convolution, after that you have applied some fully connected neural network, and you got the output. Suppose this is dog. Okay, now again in the second prediction, if I pass another image of cat, okay, to the your model, it will do some analysis and it will give me the cat. So will it be able to understand the previous input you passed? Guys, tell me. It would be able to remember what was the previous input. Just write yes or no. Anyone, guys? See, I think you are getting, like, see, if you pass in the first prediction dog and the second prediction cat, will it remember the first prediction was dog? No, right? Completely you will see a new output here. It will not give you the dog also. Like my previous input was dog, it won't be possible. Okay, that's why it can't remember the previous input. Okay, anything. If I talk about CNN, ANN, okay, suppose if I pass one rows here, like name, fair, okay, to my model, this is my model, ANN model. Okay, name fair, it will give me survived or not. So this person suppose survived. Then again in the second prediction, if I give another one, name, fair, to model, okay, it will give me 0. Will it able to remember the previous input? No, right? But if you are working with text data, you always need to remember, okay, what was your previous input? Okay, otherwise you can't ever understand the meaning. Okay, Got it, guys? Is it clear? Just write down yes or no. Okay. Now let's discuss about sequential learning a little bit. Okay. So here, let me show you one presentation. Yes, you can do text classification. See, I think it's just I mean, common sense. Like I showed you RNN. Okay, how it is working. It is working on sequential data. And what is text? Text is a sequential data. So definitely you can do text classification using RNN. Okay. So here, text can also be sequential data. So example of sequential memory. So this is one sequence, guys. A, B, C, D, E, F, G, H, size, A, K, L, right? This is one sequence. Now just relate to it yourself, guys. Just relate it yourself. This is another sequence. It is like the flip sequence, like Z, Y, X, W, V, U, T, right? Guys, okay. So just consider yourself which data you have trained on. This sequence or this sequence? First sequence or second sequence? Tell me. Like from your childhood, which data you have trained on? This first sequence or this second sequence? Right? ABC. First one. Now, if I ask you, just tell me what will come after Z or what will come before W. Would you be able to do like tell me? It would be very hard for you, right? You can't remember this thing, right? You will only able to answer me this one because you have trained with this one. If I tell you what is the previous of like D, you will able to say it's C. It was C. If I tell you what is the after of B, you will after of A, you will tell B. Okay, it is like very easy for you. Okay, so that is what in the so this one actually the same thing I'm telling. If I tell you what is the alphabet will come after H, you will be able to say it's I. Okay, if I tell you what would be the next, you will say it's J, but you can't tell it one time. So for that you need to count it. Like if I tell you what is the uh, character after I, so what you will count? You will count H, I, J. So these two things actually you need to count, right, guys? You can't answer me in just one time. So for that you need to count these two things. Then you will be able to say it's J. There would be some of the person, if they have good memory, they would be able to tell me. But most of us actually what we do, if I tell you what is the like character after K, so what I will do, I will just count A, B, C, D, E, F, G, H, I, J, K, L. Okay, so I will count all the previous character, then I will be able to tell it will come okay after that. Am I right, guys? Just consider from the philosophy, right? So am I following any sequential information here, guys? To predict this L, I need to know my previous like sequence also, right? Now just tell me the explain I have shared. Okay, explain I have given in the notebook. I mean in my whiteboard. Is it clear or not right now? What is the sequential learning? What was the drawback with ANN? What was the drawback with CNN? Okay, because it can't know the previous sequence. Okay, previous input we had given. And text is all about like sequence. Okay, here following. Now let's clear my board. So yeah, so that means sequential data is easier to remember. RNN are abstract to concepts of sequential memory. Okay, so now let me discuss about like the RNN architecture. Okay, RNN, like how RNN neurons look like. Okay, now there is two neurons you can see. Let me do annotate again. This is one neurons. This is one neurons. Okay, this is nothing but the RNN cell. Okay, this is nothing but your you can say perceptron, or you can say just single neuron. Okay, single neuron, right? Now just see the comparison. Okay, see the comparison what they did. Researchers thought, if I want to understand or if I want to remember my previous input, okay, what I have passed, so how I can do that? Because if you see the simple cell, if you give X input, you will get Y output, Y hat as the output. Okay, if I give again X1 input, I will get Y hat 1 output, but it won't be able to remember the what was the previous input, right? But here what is happening, if you are passing X input, you are getting Y1 output. Okay, and again this Y1 output I'm again passing as input. Okay, I'm passing as input. So in this next cell, what will happen? Suppose let me draw one neuron here. Okay, so what you are doing, again you are passing X2 output input, and with that you are also passing the previous output of the X, this one. Suppose this is neuron 1, this is neuron 2. Okay, you are passing this input, this output also. Okay, like the Y1 you got plus Y1 you are passing, then you are getting something to Y2. Okay, that means you are, whatever output you are getting from this cell, okay, you are again passing to as the input to the next cell. Okay, now it is able to get to know, like it is also taking the new data with the previous input you have given to that cell, right? It is also taking that information. Now if I take another cell here, okay, so if I give x3 data, okay, it will also take what, Y2. Okay, because Y2 it will also pass, so plus Y2. Now it will give me Y3. Now just try to understand what is happening as per you are giving new text. Suppose this is hello, I'm giving H, this is E, this is L. Okay, so what is happening, hello, first of all I'm giving H. Okay, it's taking H. This H actually, after doing prediction, it is passing to the next one H. Okay, with the E also. So this cell is getting to know, before E I had something called H. Okay, before L I had something called E. Got it, guys? No, it's not like that. It's the output. It's the output you are passing to the next cell. See, this is a single one, that's why it is looking like that, but you need to unroll as per the time goes. Okay, I will draw it in my board. I will show you what is unrolling. Yes, that is why I'm telling, because L, it is also getting, it was E, and also getting it was H, because I have multiplied. Okay, now H and E has been multiplied and it has completely a new value. That means H you can compare. Hidden state means this is the hidden state. Hidden state means this is the feedback mechanism. Okay, this is the feedback mechanism they have implemented. This is the same inside you have neural network only. Okay, but what they are doing, they are just adding one thing, that is the feedback mechanism. Okay, I'm explaining another time. So basically what is happening, suppose this is the simple RNN cell. If you give X here, you will get Y as output. Okay, if you give again X1, you will get Y2 as output, but it won't be able to remember what was the previous input. Okay, but here what is happening, if you pass X1, okay, as input, it is going, okay, again after it is predicting something like Y1, this Y1 it is passing again as input to the next cell. Suppose let's consider next cell. Okay, next cell. So what is giving, if I pass X2 here, with the X2 it will also pass the Y1 from the previous output. Okay, plus Y1, it will give me Y2. Okay, then if I take another cell, okay, so if I pass X3, so with the X3 what it will take the previous output, like this one, this was my Y2, so it will again pass to here as input, so Y2, and it will give me y3. Okay, that's how it is taking the previous output of the cell. Okay, now just consider I'm passing some text like hello, H E L. Okay, now in the first time stamp, suppose this was time t. Okay, time t. So time t, I have passed H. Okay, and it had output something. Okay, it had output something. Okay, now t plus 1. Okay, t plus 1. This was my time started. Now this is my, like, you can say, new time, t plus 1. At that point of time I'm passing E. Okay, E I'm passing. With that, it is also taking the last output of the time t. What it was? It was y1. Okay, y1, that means it was H. Okay, with E I'm also passing H. So now it is able to get to know, like, before E it was H here. Okay, now in the time 2, okay, I'm passing L. So L is taking the previous two input. Previous two input means where y2 plus your y1 also. Okay, now it is able to know, like, before L I had E and I had H. Okay, that's how it is remembering the previous input. Yes, just consider x1 is like your H. Okay, x2 is your H. Okay, like, I'm just considering some variable name here, that's it. But usually you are passing hello, HELL. Okay, now as per your word will be like, suppose you have 7 length word. Okay, just unroll it 7 times. The output y1 can't concentrate the hidden state. What you are telling, Sadish? Guys, how many of you clear with that? Will it remember character by character or word by word? It depends upon the data you are passing. Okay, suppose if you are passing as character by character data, so it will remember the character. If you are passing word by word data, it will remember the word. If you are passing sentence by sentence, it will remember sentence. Okay, because it depends upon the encoding you will be doing. Okay, suppose if I encode, suppose how I encoded the previous one, like my name is Bappy. So my I have considered as 1000, right, guys? But you can also encode like that. M you will be encoding separately like 0. Y you will be encoding separately 1. Okay, it's totally encoding format you will be doing. But mostly we don't do character encoding. We always do word encoding. Is it clear, guys? Okay, this thing would be more clear. Just give me a while. I will draw it one time. Now, let's take one chatbot example. So in chatbot, you are telling what time is it? Okay. Now, suppose you have made one RNN, like you can say model. You are telling what time is it. So if you see in the first cell, timestamp 1, it is passing what? Okay. Now in the second timestamp, okay, like this was time. Let me draw it. Sorry. This is time. Okay. This is time t. This is time t plus 1. Okay. Now you are passing time. Okay. Now if you see the output you are getting from the first cell, it is passing to the next cell, right? Just consider the color. The first cell color was this little bit darker color. The second cell color was like this color. Okay. Now what it is doing, it is taking this new input with the previous output also. Guys, is it make sense? Like, see, by seeing the picture. Now this cell knows actually what was the previous output of my previous cell. or like what was the previous input of my previous cell, like it was what, see what information it is capturing also. See, this is the color of what, right guys? And also it is capturing the time, see the current input. Now if I go a little bit like here, the second, I mean the third one, now you can see here the your current input is okay. With that you are taking the previous input also, okay, previous feedback also. So what is there, time is also there, with ease is also there. Just see the color. Again you are taking current input as it, okay, it is taking the previous feedback also. Now what is there, then your time and ease is also there, and with the it is also there. Now as per your word is like sentence is like getting more bigger, see it is forgetting the previous feedback, right? The first feedback it is almost able to forget, right? If you see the color guys, just see the first color, it is almost forgetting. So just relate with yourself. If you're learning this RNN, okay, if you just attend suppose 6-hour lecture, will you be able to remember the first 1 hour what I taught, guys? You will be more remembering what the current, like the current hour I am teaching, right? Just consider the philosophy. Like if you're learning something, so the current learning, okay, the current learning you will be learning, you will be remembering that thing. But the previous learning you have learned, you will be forgetting a little bit, right? Just write yes or no. Okay. So that's how actually RNN also works. Okay. So this was the drawbacks of RNN also. So what will happen? RNN will work fine if you have a small length sentence. Okay. Once you are increasing the length of the sentence, that means you are forgetting the previous feedback. Okay. To overcome this issue, researchers has came up with something called LSTM. That means long short-term memory. Okay. Long short-term memory problem. They were able to solve it using LSTM. Then LSTM also was having some of the issue. They came up with GRU, gated neural network. Okay. This architecture had some issue. They came up with encoder decoder. Okay. With that, they have came up with transformers, and transformers is the current one of the biggest, you can say, model, one of the powerful model. It can remember all the sequence. If you are passing like 1000 length also, it doesn't matter. Okay. It will automatically learn. Okay. That's actually evolution happens actually. Now this picture is clear or not, guys? Just tell me. Just see the picture as a like high level overview. What is happening? Basically, you are taking different cell with different timestamp, and you are passing your sentence as a word by word. Okay. And it is taking the previous information, that means previous feedback, like what you have passed, okay, in that cell. It is also taking with the current state. That is the concept, guys, of RNN. But as of now, you have learned ANN, CNN. It was not there. This kinds of feedback state was not there. We are directly passing our input. We are directly getting our output. That's it. Okay. So at the end, what you are doing, you're predicting something like at the last cell. Suppose you want to do what would be the next word after that. Okay. You want to predict. So all the information you are getting will be passing to a forward neural network. It will predict. It will classify like what time is, it would be it. Okay. Let me write. Okay. It would be what time is it? What time is it? Okay. It is 10 a.m. or 11 p.m. Okay. It will be able to predict because first of all, you will be training your data. Okay. So this is the overall concepts. Okay. Yesterday, I think I showed you one example, like Gmail example. It was suggesting something, right? If I write hi, how are you? It was giving like how are you? It was suggesting, right? Are you? Because it was suggesting this portion. Okay, it was basically applying this RNN. Basically, you are passing this one, okay, one by one as input, and this one actually it was trying to predict, okay, whether it should be R, U, or not. It was one of the example of RNN. So now in the voice output 5, we have full semantic information. Yes, output 5, you have all the semantic information. Okay. Now, see, just consider yourself. Suppose you are in the position of output 5. That means timestamp 5. Okay. T5. That means you know the previous input. What time is it? It would be easy for you to answer the time, right, guys? But suppose you don't know. Suppose you only know it. After it, what will come? Will you be able to answer me? To understand the entire questions, you need to know the what was the like previous words. Okay. Same things works with the machine also. Okay. Now it would be able to generate something like it is 10 p.m. or 11 p.m. It will tell me, okay, at least it will tell me anything. But if I just give input, if I don't pass the previous feedback also, it won't be able to understand like what I want after it. Monu, I think it should be clear, right? All right. Okay. Okay. So I can give you one example also here. Yes, you will get some numerical value here at the end. Okay. Because see, behind the weight will be calculating with your input data. Okay. And you will get some of the information. Okay. You will get some number here. And this number will contain all the information. Okay. See, just consider the number as a color. This number will contain all the colors. Okay. Colors means was your previous feedback. Okay. Because at the end, mathematics, if you consider as a mathematics, everything you will be representing as a number. Okay. That number will have a weights. Okay. That weights will contain these are the information. Advik, I think now it should be clear. See, it's just a relationship. It will learn the relationship. Okay. Just consider as a number. Imagine mathematics in your mind. Okay. If you are not, then just imagine the color. Okay. Just see the color. First input you have given it is what? Second input you are passing time. With the time, it is also able to like consume the word what information. Third example you are passing is. It is also taking the is. With that, it is keeping the information of time and what. See, time color and what color. Then fourth input, it is taking it, but it is also getting the information of this what time is. But if you see as you go ahead, it is forgetting the first input you have passed, right? See, it's like very close. It is almost forgetting because I told you RNN can't remember the long sequence. Okay, it only works with the small sequence. As your sequence is increasing, that means it will forget your previous. Just consider with yourself. If you are learning something now, it would be you will be remembering that thing, okay, very well. But if you learned something, suppose 1 year back, okay, will you able to recall that concept? You have to revise that one, right? So that's actually just relate with the philosophy always, because neural network is all about mimic of the human brain. See, RNN is a little bit like very harder architecture and it's like very big architecture, then always learn it as a cell. Okay, inside cell you have a neural network only. Okay, if you see convolution, you can visualize the convolution. Okay, like stride filters you can see, but it's not possible here to visualize this one. Always consider as a cell, unroll it as a timestamp. Okay, try to pass your words. Okay, and at least see like if you are passing these words, how it is taking the input from the like previous feedback. That's how. Okay, because as you go ahead, whenever you will be learning encoder decoder, inside one cell you will have thousands of RNN cell only. If whenever you will be learning transformer, inside one cell you will have thousands of encoder decoder architectures. How you will visualize this one? Okay, that's why just consider as a cell. That's why it is still like little bit, you can say, I mean, what I can say. Okay, you can't visualize this one. Black box types of you can consider. Okay, now let me give one example why it is needed. Suppose there, let's give one self-driving car. Okay, self-driving. Okay, self-driving car example. Let's give one example here. Suppose you have one route here, two route. Okay, suppose there is one car, it's coming with some velocity. Okay, with some force. There is another car, it's also coming. Okay, now to understand your self-driving car, okay, suppose it is coming, the speed of this car s1, speed of this car s2. Okay, now suppose this is one self-driving car, this is one self-driving car, this is one like manual car. Okay, now to overcome the collide, okay, you need to understand this car actually, you can talk about position. Okay, this car position, you need to always map this car position, like what was the previous state of the car, what was the speed of the car. Okay, with that also this car, what was the previous position of the car. Okay, what was the speed of the car, you need to also consider. Based on that you will be taking a decision, I need to increase the speed to overcome the collide, or should I decrease the speed to overcome the collide. Okay, so that is why actually sequential learning is everywhere. Okay, you need sequential, like the previous state also you need to always consider what is your previous state. Based on that actually you will be taking the decision. Okay, otherwise what will happen, you will also like run your car, it will also run his car. Okay, and there would be a collide. Okay, there will be an accident. So that's why actually previous state is matter. Okay, those who are from like electronics background, I think they are familiar with these kinds of gate, right? Feedback gate. You have, I think, learned from your digital electronics, right? OPAM, yeah. Okay. So basically the idea came from here only. Okay, like somehow I need to give the feedback to the next cell, okay, as input, so that it can get what was the previous feedback. Okay, now let's give some of the example. As we saw our RNN, Okay, this is our input, this is our output. Okay, and what will happen? There would be a feedback state. Okay, that means the output y1 you will be getting. Okay, it will be passed to this, okay, like as input to the second cell. So now this is just one cell I'm talking, but as per the time goes, okay, as per your word, suppose I'm passing one words here, that is hello. Okay, now let's first of all unroll it as per the time. So I will create some of the cell here, C1. Let me draw it. C1. If you pass x1, it will give suppose output 1. Okay, then it will take some feedback. Okay, so initially if you are defining your first RNN cell, okay, what would be the previous feedback? What would be the previous feedback value, guys? Can anybody tell me? Because there I don't have any other cell. So initially what would be this value, this f value, f0 value? Anybody tell me? It would be 0, right? Initially. Okay, then you will passing this, you will get some feedback. Okay, that should be suppose f1. Okay, f1 you will passing to the next cell, C2. Suppose you are passing x2 as input, you will be getting O2 as output. Okay, now what you will get suppose feedback 2 here. This feedback 2 you will be passing to your next cell, C3. C3 will take x3 and it will output O3. Okay, and you will get f3, feedback 3. This feedback 3 again you will pass to your C4, cell 4. Okay, then x4, it will output O4. Okay, then again you don't, suppose it depends upon like how many unique words you have. Suppose I have 4 unique words. Okay, like what I have H, E, L, L. Okay, this is my 4 unique words, and I want to predict. Okay, I want to predict the next one. What would be after that? Okay, so basically what you are doing in the time one, this is the time 1. Okay, you are passing H. Okay, H as an input, then you are getting some output. Okay, with the feedback, then this feedback you are passing to a next cell, you are passing E. Okay, with timestamp t plus 1. Okay, what you are passing also, so you are basically giving E. With that you are giving what? With that you are giving passing also H. Okay, H means your output 1. Okay, then in the timestamp t2 you are passing L. Then again what you are passing, you are giving the feedback 2. Okay, like plus f2 plus again you are giving f1 because your previous feedback. Again time t3 you are passing L. With that what you are giving, you are giving f3, f2 and f1. Okay, and at the last you are trying to predict what would be after that. Okay, it will try to predict, it would be O. Okay, because you have already trained the data. Okay, that's how actually it will unroll as per the time. Okay, and input would be what is your unique word size. Suppose here I have defined character wise, just define like define just word wise, like I am Bappy. Okay, Bappy Ahmed. So now you can see I have 4 input. Okay, so before M it was I, before Bappy it was M and I both, before Ahmed it was Bappy, M and I. Okay, now guys it is clear like how it is unrolling as per the time, but I showed you just one cell like that, it will look like that, but as per the time it will just unroll. Okay, Now, if you have understood this one, now let's like discuss about some different sequential architecture. Okay, because it has some different architecture also. Like not only this architecture, it has different architecture. Back propagation words is like similar wise. Okay, the way back propagation happens in your neural network, because I told you inside this cell there is nothing, only there is a neural network. There is a neural network, ANN. Okay, ANN is predicting something. That prediction you are giving as a just forward feedback. Got it? Okay, but I told you like RNN, recurrent neural network, is little bit black box. Okay, so you can't actually visualize these things because inside a cell there should be thousands of neural network. Okay, so that's why actually we can't visualize. Okay, got it. Now let's discuss about the different types of sequential architecture. Okay, after that I will giving one break. Okay, then we'll be starting with the practical implementation. Different sequential architecture. You have many to many. We also call it sec to sec, sequence to sequence. Okay, now what is the architecture? This is the sequence to sequence. That means you are passing x1, x2, x3, x4. You are getting as output 1, output 2, output 3, output 4. Okay, no, it is sequence to sequence. Okay, you are passing a sequence, you are again getting a sequence. So what would be the application of this? What would be the problem statement? Suppose as per the problem statement you need to define the architecture. So I can consider I this architecture I use to do the translation. Okay, like English to Hindi translation. So can I do it, guys? Because I need a sequential information, right? I'm passing H, hello. Okay, it should return something as a Hindi, right? That's why we call it sequence to sequence, sec to sex. Okay, many to many. Yes, I will discuss. Just are you clear with many to many, sequence to sequence? Just consider any application in your mind. What can be? NER also we can use. NER, name entity recognition. How? Because if I pass hello, what is the NER of hello? Entity of hello. It is objects. Okay, or greeting. Then I am Bappy. Okay. I is what? Its subject. Am is what? Is its verb. Bappy is what? Its name. See, LSTM when we'll be discussing at a time you'll get. Okay. Because the drawback of RNN is like the sequence of the length. Okay, input sequence. As you increasing the length of your input, okay, it will be forgetting the previous state. Okay, so I think the image I showed you, right? So that can be solved by using LSTM. LSTM actually can also remember long time. Actually, if you are passing long sentences also, it would be able to remember. Okay. So this was actually sequence sec to sec. Okay. suppose you have trained your data. Okay, suppose initially what you need to do, you need to train your data. You will be passing H as L and your Y as a O. Okay, then B A P P. Okay, Y as Y. Okay, then you are training your model, right? Then after that, you are trying to do some prediction. So then will it be able to do it? Because your neural network will learn. Okay. See, when we'll discuss LSTM, because LSTM, to understand LSTM, it's like a little bit bigger concept. Okay. Today, I think it's not possible. Try to get the idea of RNN today. Are you clear with RNN concept or not? Umesh, how RNN is working? What is the drawback of RNN? How it is unrolling as per the timestamp? Okay. I think it should be clear to all of you. It's like very, I mean, understandable. Just always compare with your human brain only. Okay. Because see, in NLP architecture, mathematics is not required. You don't have to understand. Okay. It's already covered before. Arun, which one? RNN? See, I think you might learn from somewhere, but there are many person like they're starting for the first time. Okay. So that is why we need to go as per our sequence. Otherwise, if I start like teaching LSTM, so they won't be able to get. Your output is your feedback only. Okay. Vignesh. Okay. I think it is covered because of the time series, I think, problem, right, Arun? But in NLP, actually, it's different. Okay. Yeah. Now, this was like sec to sec. Now there is another architecture you can call many to one. Or you can also call it sec to vec. Okay. So what is sec to vec? Yeah, you can talk about Gmail suggestion. Yeah, guys, that's what I want. Just imagine some problem statement by seeing the architecture. What can be? Okay. That means you have many output x1, x2, x3, x4, and you are getting just only one output, which is y01. Okay. So what would be the application? Gmail suggestion. Then classification, right? Sentiment analysis. Yes. Okay. Sentiment analysis, you are giving too many of sentiment. You are just trying to predict whether it's positive, okay, or negative. Okay. So this was sec to vec. Now you have something called one to many. Okay. So one to many, you can also call it vec to sec. Okay. So what is the architecture? Okay. So basically you are passing just one input x1. You can talk about text generation. Okay. Music generation, text generation. You are giving just small text here. It is generating something new for you. Okay. Now, again, there is another architecture, one to one. Or you can talk about vec to vec, which is nothing but that is your single cell only. Okay. Feedback. So this thing actually use to build this entire architecture around. Okay. Now I believe this RNN part is clear, guys. To all of you, what is sequential learning, why RNN is needed, how RNN is working, what are the architecture behind RNN. Can we do some practical? Okay. But before that, let's take 10 minutes of break, I think. Example of wake to wake, like what I can say, wake to wake example. See, wake to wake architecture you don't use for real world like application, because wake to wake actually you use to build your this architecture. Okay, because you unroll. Okay. Yes, is email suggestion. They are using bigger model, BART GPT, but at the end, inside BART GPT, the cell I'm talking about, at the cell RNN is there. Okay, RNN LSTM is there only. Okay, just consider, because GPT BART is what they have combined these are the thing in just one cell. They have created some bigger architecture, right? But the concept wise, demo wise, it is working like that only. How it is unrolling the value, how it is getting the feedback from other cell. Okay, that's why I told you it's not like easy to show. Okay, it's always you just need to imagine in your mind. Okay, it's kind of black box kinds of thing. Okay, but this was the root actually idea they have came up with. Like that's how actually we can understand our previous state or understand our previous feedback. Okay, what we are passing as the input apart from your CNN and RNN. Okay, this is the difference of RNN, sorry, ANN. And this is the difference of like your apart from your ANN, CNN, and this is the difference you will get inside your RNN. That's it. It's same only, but it has the feedback state only. Okay, that's it. Now let's take 10 minutes of break, and now I think we can start with our practical.
Is everyone back, guys? Okay. Pallavi, I will discuss it whenever I will be discussing LSTM. Okay. Like there are some state you can see it's not required state and stateless. This is not required. Again, there's some slight modification inside RNN because see RNN variant you will get a lot. Okay, there are many variants. You are not supposed to learn all the variants. Okay, just get the like fundamental concepts of it. Okay. Yes, we'll discuss whenever we'll start with the LSTM. Okay. So now let's do some practical. So I'm sharing this notebook with you so that you can also follow. Okay. So first of all, what I will show you, I think yesterday, you remember, I told you I will show you one like what embedding technique or what, I mean, you can say there was embedding layers. I think you remember. I shared one notebook. Anybody remember? Kera's embedding layers. Okay. So today I will show you this one. Okay. How to work with. And before that, I will show you another one, like how to do integer encoding using Keras. Okay. Because here we are not supposed to gain the highest accuracy. Here we are trying to build one, I mean, RNN model. Okay. And I will show you like whatever we have learned, like this encoding technique and all. Okay. Like if you have a raw data, like how to apply. Okay. So this is one of the new encoding technique you can talk about, like integer encoding. Okay. But you won't be getting good results with that because it can't also get the semantic meaning. Okay. For that, it is recommended just try to go with embeddings layer of this Keras. Okay. I will also show you. But before that, let's show this one first of all. Okay. So what I will write, how to do integer encoding. Okay. So first of all, let's take a data. So I prepared one data here. Let's connect the notebook. Select the runtime as GPU. So this is one list, and in this list, I have kept some of the examples, some of the sentence. Okay. So what I need to do, I need to convert it to numbers. Okay. So what I will apply something called integer encoding, and I will use Keras. Okay. Because those TF-IDF, what to bake, I showed you. You can use it like this bag of word, but mostly whenever you will be working with this neural network like RNN, LSTM, transformers, you will be using their layer only. Okay, encoding layer, embedding layer, this layer you will be using. You won't be using this one. But if you are working with machine learning, at that time you can go with TF-IDF bag of word. Okay, it will do your job. So that is why I'm showing you this one. So this is my one documents I have prepared. So now what I need to do, I need to import. First of all, what I need to do as per your, I mean, yesterday's session, I think you remember, I need to tokenize that, right, guys? Because this is the raw sentence I have. First of all, I need to tokenize this one, right? So let's import from Keras dot preprocessing dot text Okay, I will import tokenizer. So this tokenizer, yesterday we used NLTK tokenizer. We created our own tokenizer using split function. But if you are using Keras or PyTorch, they have already this kinds of tokenizer class. Okay, so you don't have to write your own. So I'll import tokenizer. Tokenizer objects I will be defining, and here I need to call my tokenizer. And there is a, parameter you can pass, something called OOV. Okay, out of vocabulary. That means out of vocabulary tokens equal to, you can make it as nothing. Okay, why I'm making it as nothing? Sorry, it should be like that. Okay, suppose whenever you are doing tokenization, okay, suppose let me take my annotator. Suppose you are tokenizing, these are the sentences, okay? But you will be training your these sentences, and you are pretty sure like these sentences is like presented, okay, in your data. But in future, like someone is passing new word, suppose they're passing suppose some other words like Bappy. Okay, Bappy. So, but your tokenizer actually, didn't see this Bappy in this corpus. Okay, so whenever you are doing the prediction, you are giving this word. So whenever it will do the tokenization, so it will assign nothing to this Bappy. Okay, so this is the use of the nothing. So you can give nothing here, your name, my name, it's fine. Anything you can give. So basically you are telling, if in future some out of vocabulary is there, okay, just define with this nothing. That's it. Okay, let me clear. No, it won't hold the docs. Okay, it will learn, like it will learn the tokenization. This tokenizer objects actually you need to save somehow. Okay. So this is the tokenizer object I have defined. Now what I will do, I will just call my tokenizer. Now see, I have defined the tokenizer. Now what I will do, I will fit on my text, right? Fit on my text. So I'll just write fit. Fit on text is there. Okay, fit on text. Now just pass your docs. Okay, pass your docs here. So now actually it has fitted. Now what it did, it did tokenization. Okay, like what was tokenization? Like if you see, it did some split operation. Okay, and now what I will do, I will generate what I will generate an index. I will assign an index. Okay, so what it will basically do, let me open my board. So integer encoding means what you want to do. Suppose you have a word here. My name is Bappy. Okay, so what you are trying to do, first of all, you will be tokenize, right? Tokenize all the word. So it would be my, then it would be name, is, and Bappy. After that, you will be defining some ID. Okay, so suppose my will take 0, but a name will take 1, is will take 2, Bappy will take 3. So it will have some ID. Okay, now I have this ID. Now can I represent now right now? If I want to represent my name is Bappy right now in the encoding form, so I will write 0, 1, 2, 3. So this is basically your integer tokenization, integer encoding. Is it clear, guys? Okay, that is what you are doing. Now let's see the programmatically. So I have fit my tokenizer. So it's basically splitted all my words, all my unique words. Yes, label encoder you can talk about, but it will assign some of the random value. Okay, I'll show you. So now if I want to see, okay, if I want to see word index. Okay, basically tokenizer automatically will assign some of the index to your every word, every unique words. Okay, now if I want to see, so what I will write, tokenizer, I can, yeah, tokenizer word dot word index word. Okay, I think it should be word index. Now guys, can you see each and every word has contained some of the like ID, nothing has content. See, because it was nothing here. Why it is taking nothing? Because if you just pass the out of vocabulary in the first phase, okay, it will take this one, it will assign at the first position. Okay, then it will assign as 1. Now it was a neural network. Okay, neural has been assigned to 2, network has been assigned to 3. Okay, then if you see each and every unique words has been assigned with some of the like number. No, like during prediction, you need to write a function. There actually you need to pre-process your prediction data. Then you will pass that data after converting to a number. Okay, you can't directly pass your text to your model. Okay. Yes, curly bracket you need to write. Okay. Why reassignment before nothing? So this is like if you are giving any token, like in NLP, actually, if you give nothing like that, so nothing might be included in your documents only, right, guys? It might be possible nothing word should be presented in your documents. At that time, what it will consider? This nothing would be same. But what I'm writing this bracket because I'm representing as a token. I think it should be clear now. New words. Recurrent is why recurrent is OV. Which one you're talking? This one. See, here I'm not defining any recurrent. No, recurrent has been nothing because see, nothing will take it and it will assign as a first position. Okay, don't consider it will replace recurrent with nothing. Okay. Now recurrent is there. If you just find, see, recurrent is there. Got it, guys? Whatever you will pass here, it will assign as a first position. That's it. Okay. And every word you will see here in there, it will present here. It's not like that it will replace. Okay. Is it clear, guys? Just write yes. I think it should be clear. Very easy. Okay. Now, if you see word counts, like there are some words that has been included 2 times also. Okay. Now, if you want to see word counts, it is also possible. Just write tokenizer dot word counts. What counts, I think, yeah. Okay, tokenizer, how's it as what counts? It should, okay, sorry, it should be what counts. Okay, now see, neural is coming 4 times in this documents. Neural 4 times it is coming. So that's why it's counting each and every one. Okay. It is also possible. Now, if you want to see the document counts, like how many documents you have in these documents, okay, like how many rows you have, it is also possible. Just write tokenizer dot document count. See, all the thing is like built in inside your like Keras, TensorFlow, PyTorch, whatever you are using. Okay, so that is why I told you yesterday, if you are working with machine learning, at that time that notebook will help you because there I have kept all the functions and all. Okay, but here if you have already all the things pre-built, okay, you don't have to worry about that one. So now I have 11 rows in my documents. If you can count, I have 11 rows. Okay, so that's why it's taking 11. Now, what I need to do, I need to convert, because see, now it is still like what? Still like what? Okay, English word, and it's some ID. But what I want to do, I need to convert completely to a number. Okay, I will represent like that only, like my 0, I'm keep 0, name, it is 1, 1. Okay, that's how I want to represent this one. So how I can do that? Just write sequence. Let's define one variable called sequences, and here I will call my tokenizer, and I will just call a function called text, okay, to sequence, text to sequence, okay, and pass your documents here. Okay, if you pass it and if you just print your sequence now you will see it has converted to completely number. Okay, how? Now let's see. So what was my first one? A recurrent neural network. Okay, so what is the idea of R? Just find out. Recurrent 7, right? Now if you see, it is 7. Now neural, what is the neural ID? It is 2. It's coming as 2. Then what is network? Network, it is 3. Okay, now if you see here, it's 3. Okay, with respect to that, how many sentence we have defined? All the sentence would be converted to numbers. Is it clear, guys? Yes or no? How it is converted to numerical? Is it clear? Okay. Now tell me one problem here, guys. Can you observe by seeing this array? What is the problem here as per your observation? Anybody tell me? Length is not same, right? What I can do? Okay, padding I can add, right? Okay, now let's add some padding here. Okay, from Keras. This is not recommended, adding padding, but somehow I'm doing this one. Okay, I need to do it. Okay, utils. Then I need to import pad sequence. Now again, I will define a sequence. I will call my pad sequence class. And here I will pass my sequence. Okay. And there is a parameter you need to pass, padding equal to post. Post means you want to define as 0. Okay. Now, if I again print this one, now see, issue is resolved. The like where you can see it was not matching the length, it is added with zeros. Okay. Now you can ask me, like, you told me adding 0 is not, I mean, good approach. Okay. But I mean, that was in the one-hot encoding. Okay, one-hot encoding. One-hot encoding will see the maximum length of the, I mean, your words, okay, or sentence. With respect to that, actually, it will define the, I mean, your encoding, right? But here we are not doing the encode. I mean, one-hot encoding. Here, what we are doing, we're assigning each and every unique words as a number. That numbers we are converting to our encoding. Okay, now I think you got it. So this kinds of zero padding, it's not like, I mean, it's not like very, you can say, I mean, you can say it's good. Okay, it's good. You can add it. Okay, that kinds of 0 you can add it, because here your length is not increasing. Okay, but don't apply one-hot encoding because it will, I mean, increase your dimension. Okay. Now my data is prepared, guys. Now I think you got it, like how to prepare, how to do integer encoding if you have any custom data. Okay. Now let's do the same thing on the IMDb data set. Okay. Now let's implement one sentiment analysis. Sentiment analysis. Sorry. On IMDb data. IMDb movie data. I mean, I think you should be familiar with the data. So first of all, let's import some of the packages. So I need from Keras. I need the data set. So already import this data set. Okay. And this data set is actually already pre-processed. Okay. You don't have to pre-process it. IMDb. Now from Keras, import sequential okay, sequential. Then I need some layers. So from Keras dot layers. Okay, what I need dense layer. Then I need simple. See, I am implementing RNN. Okay, so there is a class called simple RNN. If you want to build RNN, okay, so you need to call it simple RNN. And embedding I'm not going to use here, so I won't be importing. I need a flatten. Okay, so these are the layer actually I need. Now you can load your data. So just define xtrend, xtrend, ytrend. Then you have xtest and ytest. Now let's load our IMDb. IMDb dot load data. Now, if you want to see the data, so it will look like basically like that. Okay, it is already encoded. Okay, and what encoding they have applied? They have applied this integer encoding. The way we did the encoding on the data, the same way they did the encoding, and they already pre-processed the data for us so that we can quickly load it and we can test our model. Okay. Okay, that is why I showed you this example. Okay, because if I import this data previously, so you would have asked me like how they encoded the data. Okay, now I think it is clear how they encoded the data. Okay, so this is movie. There are some word they assigned some with some ID, and that ID has been like replaced. Okay, now if you want to see the shape, so there are 25,000 actually reviews. Okay, in the training data, and if you want to see the test. Sorry. Okay. Extreme. Okay, both are same. Okay, like inside train you have 25,000, inside test also you have 25,000, and y is nothing but your levels, like it is 0 or 1. Okay, 0 or 1. RNN, ANC, CNN. Nagara's NLP. If you know RNN, LSTM, GRU, encoder, decoder, transformers. Okay, but GPT, that is enough. Okay, but there are some composite model. What they will do, they will combine like CNN and RNN together. Okay, like there is one project I can show. Generate image caption. Did you heard of this like project before? Image captioning. If you just input one image, it will tell like what are the objects are presented inside the images. Now, if I generate the caption, so let's see what will happen. is generating. You can try this website I'm giving you. Yes, basically what they're doing, they're also including CNN architecture. They're also including RNN architecture. Okay, so by CNN architecture, they're extracting this feature. They're trying to know what are the objects are there. Okay, and that has been passing to your RNN. RNN is like writing as a text. Okay, so you can combine model together. You can make a composite model. Okay, it is also possible. So this is one of the application of, I mean, see, it's analyzing the image. Now generate the text. I think it will be generate something here. See, a man sitting at a table with a laptop, a group of people sitting around the table, a man sitting at a desk with the laptop. Okay. Now I think you can relate, right? Is it clear? Image captioning project. Okay. So both architecture are using here, CNN, RNN. Okay. All right. Now go back to our work. So this is our data all about. So I think you got it, the data. Now what I will do. So there actually we'll see one problem in this data. If I show you X trend, let's take the first index. So this is my data look like. Okay, this is a number. And here I have also problem. Let me show you what is the problem. If I show you my X trend first row, and if I show you my X trend, this second row, okay, you'll see this length is not same. Okay, I will call the length function. See, these are not same. So now what I need to do, I think you know it. I need to add padding, right? So now let's add padding. Okay, so I'm calling the same pad sequence. I'm passing my extend, okay, padding post. But here what I'm doing, max length is equal to 50 I'm keeping. Can anybody tell me why? Because this is the IMDb data, and here how many unique words you have? You might have thousands of unique words. No, thousands of unique words, okay? But this is the free collab right now I'm using. Okay, free collab I'm using. So if I take all the features, so what will happen? It will crash memory error, okay? It won't able to load all the things. At least you need good like system, okay? That's what I'm keeping, and it will take a like very like higher time to train. I told you padding is not good whenever you are doing one hot encoding, but here I am not doing one hot encoding. Here I am doing integer encoding. Like both has some difference, okay? Because one hot encoding unnecessary will be assigning higher spaces, right? Based on the like how many words you have, okay? But here we are not doing that. But this is also not good. Okay, I'll show you one approach, like the embedding layer, okay? Can we do like find out the max length features, then according and apply to the padding? You can do it, no issue. But here, what I'm doing, out of all the like unique words, I'm just keeping top 50 like most occur words. Okay, I'm just telling like I don't need all the like unique words. Instead of that, just give me 50 words, okay, which is like more occurrent, okay, in this corpus. Because if I am taking all the words, okay, so what will happen? I might get memory error and my training will take time, because I want to show you the demo so that's why I'm taking just 50. But if you want to train with all the unique words, just remove this two line, okay. So that is what actually I'm doing. Now if I like do it, now if I show you my extend dot shape, now you'll see it's 50 dimension only, okay. But here if you see, here if I do shape, okay, it is replaced, that's why, okay, because I have already replaced. Okay, so that's why I'm taking just 50, but previously it was not 50, it was like more than thousands, okay. That's why I'm doing like that. So now if you want to see, yeah, 2 to 1 8, I think, okay, like every sentence will contain their, I mean, different shape, okay. Now these are my most occurrent 50 words, okay, I have taken, okay. Now what I will do, I will define my model, okay. Let's define my model. Model is equal to, first of all, I need to call the sequential, okay. Then I need to add my RNN layer, okay. So add simple RNN. I think we have imported simple RNN, and here you need to define the nodes, okay. I need 32 nodes. This node is like totally your neuron you define inside your ANN, right? How many neurons you want? It's totally hyperparameter, okay. Basically what you are doing, suppose if this is one RNN cell, okay. Inside, I told you there would be some neural network, right? There will be some node. So this node actually you are defining as a 32. Okay, got it? You can take 50, 100, it's up to you. Okay, that is what I am doing here. So I'm telling inside my RNN layer, I'm just adding one layer. Inside one cell, I need 32 nodes. Okay, that is what I'm defining. And I need to define the input shape. Okay, input shape of my data. Input shape. So input shape is what? What is your input shape, guys? What is your feature shape? It's 50, right? So 50. And what I want as my output? Okay, tell me. It's 1. Yes, 30 neurons in one RNN unit. Yeah, you are right. Here I have defined 1 because why? I want just only one output, positive or negative. Okay, that's why. Now, I think you remember, you can define this RNN architecture is many way. Like there are 1-to-1, 1-to-many, many-to-many. Now tell me which architecture you want to use here. You are doing sentiment analysis. Which one would be suitable? Many-to-1, right? So now, yes, many-to-1. So now here to many-to-1, to take the many-to-1, here there is a parameter called return sequence. Return sequences, you need to make it false. Return sequence, yeah. Return sequence means I don't want any return, okay, from each and every cells of my RNN, right? So that's why I'm telling return sequence is equal to false. I just only want one sequence, okay, one output from the last layer. Okay, so that is what you need to mention here. Okay, I think it should be clear. Okay, I need to close the bracket here. So now it's done. Let's take just one layer of simple. You can take many layer. Okay, it's up to you. You can take another layer. Okay, you can take another layer. But again, computational power. Okay, and be taking. Okay, I think it's giving some error. RNN. Okay, so here I've added some extra bracket. Okay, now I think it's fine. Okay, so now what I need to add one dense layer, because at the end, every neural network, it will contain dense layer. Okay, model.add dense. I just need one. Okay, because it's just a classification. And here activation function. Activation. Which function, guys, should I define? No, sigmoid. Yeah, it's because it's the last layer. This is system. Yeah, if you want many to many, just give it as true. Okay, return sequence as true. Then let's keep sigmoid, because this is binary classification. Okay, that's why sigmoid. Now, if you want to see the model.summary, okay, so this is my model summary, and this many of parameter I have for trainable. Okay, I think it should be clear. So what is the new? I have added this simple RNN instead of our NN. Okay, that's actually you can define. Now I need to compile the model, so let's quickly do it. I already written. So model.compile, the same thing, binary cross entropy, the loss function you are selecting, optimizer you are selecting Adam, matrix wise you are selecting accuracy. Okay, now model.fit, I'm giving my training data, number of epochs I'm defining as 5. Let's decrease to 3 because it will take some time. And validation data I'm like giving X10 and Y test. Okay, let's run it. Started my training. Okay, accuracy you will see it's less because I took 50 unique words. Okay, but if you are taking all the words, so you will get like more accuracy here. Okay, that is why you can try with just remove it and train your model. You will see the like observation. And again, I took just one RNN layer. Okay, for you, you have to take 2 or 3 so that it can learn in a better way. And again, the encoding we did, it is not that much of good. Okay, we don't use it. We will be using something called embeddings layer in Keras. Okay, I will show you after that. Because as per, I want to show you quickly because I don't want to wait. Okay, that's why I given 3 epochs. You give like as per your choice. Okay, because see 3 epochs, it's taking time, right? Because there are many data, right? 25,000 data, 25,000 like reviews. Because text data usually takes time, right? Because it has a higher dimension. $50, how many, like what is your input shape? You have defined right here. Your X10 is like, if you see shape, it's 50, right? 50 features you have, that's why you have given 50. And one is like, what is the output? Output is only one because you want to do positive or negative. That is why. No, nodes is different. Okay, input shape C before 32. Let me define before 32 nodes. Okay, first as the input. Okay, what you are defining? You are defining 50, right? This is connected. It will automatically handle. Okay, we don't define this one. So what will basically happen? Suppose you have defined, you have taken one RNN cell, okay, one RNN cell. Okay. So how many example you have? Let me show you. Otherwise you will get confused. My pen, yeah. Suppose you have 50 example, right? Like so anything like 2, 3, 5. Okay, anything 50 example you have here, 50. So you have defined 32 nodes inside your, this is your RNN cell, okay, RNN cell. Okay, and this is your, just consider one nodes, it is connected, and it will give you what? It will give you output. Okay, so basically what is happening in the time 1, you are passing 2. Okay, it's doing. Okay, then again time 2, you are passing 3 one by one. Okay, now I think you got it, how it is handling. It's not like that you have defined 50 and your node is 32, it's not work. Okay, because RNN will always work with the timestamp. Okay, timestamp T4, T5, it will go till T15. Vignesh, is it clear? Okay, see, training is done. So this much of accuracy I got. Now if you want to do the prediction, it is also possible. So to do the prediction, first of all, you need to bring your data to that format. So first of all, let's see our test. Let's take the first example. Shape. It's 50, it's fine, but I need to reshape it. Okay. And because here I need to pass 1, 50. Okay, just one row. This thing I think you should be familiar with. I can write 1 minus 1. Now, if I want to check the shape again. Okay, reshape. Or what? It is reshaping my value, right? Tuple objects. Okay, sorry, its shape should be reshape. It would be able to reshape. Yeah. Now, if I check the shape, now it's 150. Okay, now let's store it in a prediction. A prediction test. Okay, now I'll call my model. Model dot fit model dot predict. I will pass my prediction test. It's giving double with the layer, expect dimensional 3. What's the issue? Okay, sorry. Can anybody tell me what is the issue here? I think I need to take. Again. X test. Oh, sorry, guys. I'm keeping shape here, right? So this is not required, I think. Okay, now it's fine. You are giving 0.5. That means what you can call? You can either call it positive or negative, right? You can call anything. Okay. Reshape 1 minus 1 means, suppose if you see this one, sorry, it should be code. This thing actually would be clear, I think, if you have learned RNN. Okay. Sorry, it should be shape. Is there any additional shape you can see? One, because this is just one array, right? 1 comma, it is a one array. That means 1 comma 50. Okay, it should be. Your model is expecting. Okay, but here is just a 50. Okay, it's just kinds of list you can talk about. That's why we are making another dimension here. Okay, if I now like give this one, so basically what will happen? It will make one dimensional at the first. Okay, that's it. Okay, so this was the sentiment analysis with this one, our integer encoding. Okay, now let's do it for encoding layers in Keras. Okay, because this is not suitable. So I'll write how to do encoding using Keras embedding layer. Okay, Keras embedding. Now let's do it. So I'll just copy paste the same thing. Vulnerability which we received output. Yes, this is the probability output. Now you need to write one if else statement. Okay, if okay, suppose prediction, you are storing as a prediction. Prediction, okay, and prediction you are keeping the value out. Okay, now if your prediction like is greater than, you can say 0.5. Okay, see, you can write any statement. If it is 0.5, so what you can call it, it's positive. Okay, print positive. Okay, and if it is less than 0.5, you can print negative. Got it? Return sequence is what you don't, return sequence is equal to false. That means what you are telling, the architecture you are defining. Okay, architecture you are defining 50 times you are unrolling, right? Because 50 input you have, so you don't need output here. Okay, like x1, x2, x3 you are passing, but you don't want the output here. Okay, you only want output at the last layer. Okay, because I'm doing the classification. So this is your sentiment, this is your positive or negative review. That's why I'm returning. Return sequence is equal to false means it will it won't give any output here. Okay, it won't provide any output here. It will only output at the last layer. Got it? No, it's not any, not calculation is there. See, RNN, is there any calculation? You just select randomly, right? As per your observation. Now, if it is not giving again, you try to increase, right? Yes, this is the example of sec to fake. Okay. Yes, always return sequence is equal to false. Okay. All right. So let's clear. Now, hope this example is clear. Now let's see our embedding like example. Okay, like how to use Keras embedding layer. So I will take the same data. First of all, I will show you like how embedding layers is working. Okay, I'll just copy paste the code. So I'm defining my tokenizer. Let's fit on my data. So now what I need to do, see, it is recommended, Keras guy has told, if you want to apply embedding, okay, embedding on your data, you need to convert your data to like first of all numbers. Okay, like number sequence till this point. Like till this point you need to do. This will remain same. Okay, then you need to pass this data to your embedding layer. Okay, so this is recommended. That is why I need to also apply. These are the steps. So to convert it to number, I think you remember text to sequence was there. Okay, so we are converting this number. Now what I need to do, I need to add paddings. I can do it. Okay, now it is converted like that only. Okay, like that only. Now I can use Keras embeddings layer. So what Keras embeddings layer will do? Okay, Keras embedding layers is nothing but it's a neural network. Okay, it's a neural network embedding layer. Basically, it has the capability to learn from your data. So what will happen? You will pass your embedding layer with your RNN layer only. Okay, so it will automatically generate. It will learn and automatically generate the embeddings for you. Okay, embeddings for you. So basically it is learning as per your iteration is going on. In every iteration, it is learning which would be the best embedding for this model. Okay. So this is the concepts of embedding layer. Basically in runtime, it will learn. You don't have to like generate the embeddings for that. Okay. But using what to make TF-IDF, okay, we used to generate the embeddings for us, like it is already trained. It is already trained. It has already the vocabulary. We used to generate, okay, the real one. But here we are not generating, we are training our embedding. It is automatically learning from your data. Okay. So that is the thing here. So how we can do it? So first of all, let's define one architecture of embedding. So basically you need to define like that sequential. Here I need to import the encoding. Okay, so let's import the encoding. I think importing we are doing here, right? Somewhere I did the importing. Yeah, so let's import embedding also. Okay, it's embedding. Now it will work now here. So here I'm adding embedding layer 23. Okay, why I'm adding 23? Now tell me. Okay, so 23, why I'm adding? Yeah, because I'm adding 23. If I show you, I have fit on my tokenization. Okay, it's done. Now, if I want to see how many unique words I have, okay, here I can also see length tokenizer word index. Okay, now if I do the length operation, I have 23 unique words, okay, in this corpus. Yes, so that is why embedding layer first input would be how many unique word you have in your entire corpus. You need to pass. Okay, you need to count it and pass it, otherwise it will throw an error. Okay, so I'm considering it's 23. Then output dimension, what you want. Okay, like each and every, if you see each and every words, I mean, what is the dimension? Okay, what is the vector you want to represent? So basically what is happening? Suppose this is one words. My name is Bappy. Okay, I'm suppose converting to numbers 0, 1, 2, 3. Now what embedding will do? I'm defining as 2 here as output. See here, 2. Okay, output dimension 2. Now what it will do? It will represent my as some number with 2 dimension, like my would be 0.32, 0.52. Okay, this is the my. Okay, again it will like represent the name as 2 vector, like 0.42, 0.92, any number. Okay, it will calculate by itself. Okay, I'm not sure the number. Again, is will be represent as 2 number, like you can talk about 0.63, 0.53. Okay, then Bappy will be represented as 2 number, 0.92, 0.83. Okay, now I think it's clear. Okay, now each and every word is representing by 2-dimensional, I mean, vector. Okay, got it? 32, why you are getting 32? Here I am not defining any 32, guys. 23, 20 means like how many unique words you have in the corpus. This is the unique words in the corpus, okay? And output means how may, I mean, what would be the representation of each and every words in the dimension, like you can say axis, okay? In this higher dimensional axis, each and every vector will be represented as 2, x and y. This is another vector, x1, y1. Got it? Yeah, it's a hyperparameter tuning. You can take 3, you can take 4, you can take 5. Again, if you increasing, computational would be high. 23 means how many unique words you need. Unique words you have in the corpus, okay? I'm counting here. If you see tokenizer word index, I have 23 unique words. Okay, and input length means if you want to see the input length, what is the input length? Okay, here the highest input length is 5, right? 1, 2, 3, 4, 5. That's why I'm defining input length as 5. No, there are 23. Just count, just make count. See, I'm not telling randomly. I have count here. See, length. Amir. Okay, and input length is like the sequences you have made. Okay, after padding, adding padding, check the length. What is the sequence length? It's 5. That's why I'm defining 5. Now this number is clear, guide. What would be the embedding inputs? Yes or no? See, tokenizer is different thing, embedding is different thing. Tokenizer you need everywhere. Tokenizer means you want to tokenize, these are the words separately. Okay. And embedding means you want to generate some embeddings. That means you want to represent the words as a number. Advik. See, embedding is what? Embedding will, as of now, what we did integer embedding. See, integer encoding we did. Integer encoding, we just represented number till now. Okay. But embedding is another technique. It's a neural network technique. It will try to get the relationship of your data. Okay, like it will learn the sequence, like after recurrent, there is a neural. After neural, there is a network. Okay, it will learn the represent of your data. But previously, I was not using that one. I was just defining my number as number. I was passing to my model, but it was not learning the sequential information of my data. But here now it is able to learn the sequential information of the data. Got it? Yes, embeddings, what to wake, TF-IDF, these are same only. But embedding you train during your model training. But what to wake is already trained and they have published it in the internet. You just download it and use it. They're pre-trained words. Got it? You can either replace with what to wake here, that model. It's also fine. Okay, but I won't be using because it is recommended. Research has proven if you are training your embedding also with the model, at that time you will get good results. It will able to learn the actual information about your data during training only. Okay, it will be able to generate that representation of your data during training only. Okay, it is proven by research. But if you want working in machine learning, at that time go with what to fake, TF-IDF, generate your embeddings at the very first, then try to feed your like naive bias or random forest and anything. Clear, guys? Now let's execute. So this is the like my embedding network. Okay. So now let's compile. Okay. So here so here you also, because this is a neural network only. Okay. Here you need optimizer and accuracy. Okay. Loss function here, it is not needed. Okay. So it is compiled now. Output dimension, like what would be representation of every words in the higher dimensional. So I kept two means two vector, it will representing, see 0.32, 0.52 is representing my. Then again, name is representing 0.42 and 0.92. Okay. In the higher dimensional space, you can increase the number to 3. Then what will happen if you increase the number, your my will be representing with 3 vector. Suppose 0.32, 0.52, 0.92. Then it would be 3 number. If you again give 4, it will represent as 4 number. Okay. We are making the dimension. And input length, what is your input length of this array? It's 5. So I'm giving as 5. Okay. Now let's predict. Okay. Now let's predict what my embedding layers has predicted. Okay. On my sequences. Now, if I print the prediction, now, as I told you, it will represent each and every word with two vectors. See, that means, first of all, if you come here, recurrent is representing with this vector here. This is the represent of recurrent. Okay. And then neural is representing with this one. This is the neural. Okay. Then again, network. Okay. That's how actually it's representing. No, it's not higher dimensionality. This is the, I mean, encoding, embedding you are generating. And this is pretty good because it would be able to learn the relationship. How? I think yesterday I showed you one graph, because if you plot this at the vector in a higher dimensional space, okay, now let's see, this is your 3D space. Okay. So here, suppose all the vector would be there, guys. All the vector are there. Suppose this is a neural, this is network, this is RNN, okay, this is CNN. Now in the higher dimensional space, which is like more closer? See, neural, network, RNN, these are closer. That means this is similar vector. Similar vector. Okay. And if you see the text here, recurrent neural network, it's just a one line. Now tell me, it is able to learn the semantic meaning or not? Guys, yes or no? Because I told you this vector is coming closer together. That means if you make a cluster, this vector is falls into two, like in the same cluster. Now neural network RNN, recurrent neural network. This is one, right? It's getting the semantic meaning. That's why this embedding layers is important. But at the previous one, I was not doing that. I'm just randomly generating the value. There, actually, it was not able to learn the relationship in the higher dimensional space. It was picking up randomly. Yes or no, guys? Tell me. Hello. Okay. Yes. Okay. Just refresh my notebook. You won't be getting an error. Just try to follow all the steps. Okay. Now let's do the what? Let's do again this sentiment analysis. Okay. Using this embedding layer. Here, what I will use the embedding layer. That is the difference. I'm importing all the library necessary. I have to load my data. Then again, I'm doing the pad sequence and I'm taking the 50 most occurred word, okay, instead of all. If you want to see the shape, you can also see. It is my training shape. Okay. Now I will define my architecture of my model. And here with, you will see, first of all, what I am doing. First of all, when your data will enter to your model, okay, it will be, first of all, generate the embeddings. That embeddings will go into your RNN layer, okay? And then the classification will be happening. I don't know like how many unique words they have, but they have, I think, more than 1000 unique words. Okay. But I'm not picking all the unique words because it will take again time to train. Again, it will take memory. That's why I'm picking most 50 occurrent words. Okay. Okay. Now tell me, yeah. Now what is 10,000s in embedding? Now I'm considering in IMDb, there might be possible like the unique words might be 10,000. Okay. 10,000. But make sure you just count here all the unique word and try to give that value. I'm just assuming it might be 10,000. Yes, time consuming task. Okay. And output dimension, I'm passing 2 because I want to represent each and every words as a two vector. Okay. And length is 50 because if you see my input data is 50 length. Okay. Like 50 features I have. And this is the same RNN I'm defining with 32 nodes, dense layer, summary. Clear? Let's execute. Now see, this is my architecture. Now if I train my model, so I don't have to basically generate the embeddings. Okay, it will automatically generate the embeddings whenever you will pass your data. After automatically generate embeddings, it will go here. It will try to like learn the sentence. It will do the prediction. It will check the loss. If loss is very high, it will again come, upgrade the embedding weights. Again, it will generate some of the embeddings. Okay. Then again, it will learn that sentence, again, do the classification. Again, loss is high. It will come, upgrade the embeddings weights. Okay. Again, it will generate some of the embeddings. Okay. That's actually learning will be keep on happening. Okay. And it is pretty good because it is learning from the real world observation. Okay. Because your RNN layer, if it is not able to get that embeddings, it's telling here, upgrade your weights, generate something good for me. Generating, again, it's taking, doing some classification, again, it's coming here. Okay. That's how, now if you see, whenever you are adding embeddings, that means like there are two actually web, that propagation is going on. One is inside your embeddings, one is inside your simple RNN. Okay. Now let's start the training. Now see, now it's taking a little bit higher time to train, right? As per previous observation, because there is two backpropagation is happening. Okay. Now guys, any questions you have till this point, or do you get the entire idea? You just check Vignesh, it's running for me. Fine. Just I'm sharing the notebook again. Just try to refer my notebook. Just open it in a new tab and try to see what you have done. Hidden state. What is hidden state you want to? Backpropagation would be happening in your neural network. Okay. Don't consider it to be happening in your cell, because I told you RNN would be a cell. Inside you will have the neural network. Here backpropagation will happen. And this is the feedback network. It will give you the input you are passing as a feedback in the next cell. Guys, are you clear? Today's agenda, are you clear? All the thing. I think it should be clear because I have explained in a very easy way. Even I showed you the code example and all. Right? Now, actually, it would be easy for you to learn the LSTM and GRU. Because now you know what is sequential learning, how RNN works, okay? How time enrolling happens, what is embeddings layer. Okay, now you all the concepts. You will get more interest when you will learn the encoder decoder. Now you think like how the researcher has taught like our imagination power. Okay, like encoding decoder actually can, what it can do actually, let me tell you. Suppose there is a sentence you can see here. Okay, encoder decoder actually automatically will get to know which word has more value to this entire, I mean, you can say corpus. Okay, suppose summarization I told you, right? So if you want to do the summarize, okay, you will pick up some of the words from this sentence, right? It will automatically get to know which has more weights, okay, to represent this entire corpus. It will automatically learn. Okay, that kinds of power it has. So it's like more interesting, you will learn at that time. Because see, RNN and LSTM we don't use, okay, usually. Those who are working in time series and all, they will be using. But if you are working in NLP, mostly you will be working with the transformer based model. Okay, the BART GPT, this one. So training is done. Now let's do some prediction. So the same thing I'm doing. I'm picking my 50 example. I'm reshaping it. I'm storing as a test data. And let's pass to my prediction. Okay, now this is the prediction I'm getting. So I can call it, it's a negative sentiment. Okay, you can write one condition, if it's condition, if it is less than 0.5, okay, so you can consider as negative, more than positive. Okay, so I hope everything is fine. Yes, you can increase the RNN layer, it's up to you, because I haven't increased because it will take time to train, right? Just increase the RNN layer, try to change the node size, do it. Okay, it's same only with your NN, but here you are using simple RNN layer, that's it, all the way. Yeah. So is it fine, guys? Today's session, I think all you have understood or not? Yes, class is concluded because today I won't be able to complete LSTM and GRU. It will take time. Even it has been like, yeah. Tell me, like, it was fine today's class? Did you got all the concepts? How's the session? Yes, most probably. No issue, Pallavi. You can go with the recordings if you want, because extra class is needed because we have so many of concepts, so we need to finish. Okay. Accuracy is less because I selected only, if you see, um, I selected just 50 like most occurrent, right? That's why. will be there data analytics and big data after NLP. Yeah, I think NLP, there would be big data class will start. Okay. So I hope it was a nice session and you all have got it. Okay. No, actually, I didn't work on big data before. Okay. Mostly I work in deep learning, CB and NLP. I told you like NER you will be using everywhere. Okay, name entity recognition or parts of speech tagging. The name entity recognition, you're doing parts of speech. Okay, so whenever you're trying to build chatbots or you can say text generation anywhere like summarization, you will be doing this annotation only. Okay, parts of speech tagging annotation. Yes, big data you can after I think your session will be learned. Yeah. Research paper wise, see you can the concepts I taught you today. Okay, just search RNN research paper, RNN paper. Okay, you will get many version of RNN paper. You will read their thing. Okay, these things are similar what I explained. Okay, but they have added some equation and all. It might get you some confused. Okay, don't worry because mathematics is not needed here because I told you it's a little bit difficult to understand because it's totally black box. You can't imagine this thing. Okay, we can visualize this thing actually. You can imagine but not visualize. Okay, then there is a sequential learning paper also there. Okay, how that's how actually you can open research paper, you can read it. Okay, but I won't suggest don't spend on that. You can refer these two books. I think yesterday I suggested it's enough. See long shot RNN, they have also included LSTM here. So all the thing actually they have mentioned. Okay, this is like a recent paper. I think that's why they have included many things. What does 700? I didn't get your questions, Ashish. Which link you want? Okay, I will share this, all the notebooks and everything. Okay. Let me share it now. I will add all the presentation and everything here. See, whenever you are defining batch size, right? Like by default, it will define some batch size. So in every, iteration, every epoch, it is taking 782 batch images. Okay, and it's training. Like a step per batch, I think you learn in NN. Sunny sir, I think taught step per epochs, I think used to define. Yes, we can drop off the call, guys. This was all about from my side today. So yeah, thanks for joining the session. Thanks, everyone.